So I'm John Mashey, and I'm delighted to be able to get oral history today of Tony Wasserman, one of the heroes of software engineering, and we've known each other 40 plus years, and especially from the era when I was doing a lot of software engineering tools and environments. So, Tony, let's start. Where did you grow up? Tell us about your background. How did you get into this?
So I have kind of this hippity hop background. I was born in the Bronx, not too far from the zoo, and my father was in retail, and so we moved as he went from one branch of a department store chain to another, that kind of thing. My mother was also in retail. She worked for Gimbel's, which of course was the rival to Macy's. And the reason I mention that is that it was number two. And my father always worked for number two. And so they would bring him into a particular city with the challenge to catch up with number one, which never happened because number one was always well established. So after a few years, we moved. That means I went to 5 junior high schools, and 2 in Ohio, and 2 in Florida, and 1 in Michigan. The last stop was Coral Gables, Florida, from which I went to the University of California, Berkeley. Thank you to my parents for letting me travel so far, but that was really a different world.
How did you happen to choose Berkeley?
I was looking at the West Coast, at the Bay Area. My father had always said that he wanted to move to California from the time that, as long as I can remember. And so when time came to look for colleges, Berkeley and Stanford were both on my list. So I ended up going to Cal. And when I was a junior, my family moved out and moved to the Bay Area. So we all ended up on the West Coast eventually. So from Berkeley, that was where I first did my programming, junior year, numerical analysis, and at the time, Berkeley's main computing center had this big dual machine, the IBM 7094 in the background.
So when was this?
It was in time for the free speech movement, so it was fall of '64. And the semester came to a rather surprising end with the big demonstrations and everything. But one of the things that was interesting was that I was a double major, math and physics at Berkeley, and discovered at some point that those were not the things I wanted to do with my life. The physics students were much better than I was, much more advanced. But I did have access to the physics lab, and they had an IBM 1620, and it was open shop. And most of the physics students didn't know how to program a computer. So I basically had a room about this size with an IBM 1620 and a card punch and a printer, and it was all mine most of the time. I didn't have any physics experiments where the computing was going to last for hours or anything. So that was fun, and I decided to go to graduate school in computer science. But this was for 1966, at which point there weren't a whole lot of computer science departments. There was Carnegie Mellon, there was Stanford, Yale was just starting, and Michigan had a communications one. So I chose the University of Wisconsin-Madison, which gave me more or less a free ride as a research assistant. And I did the department was kind of chopped up into 3 sections, A, B, and C. A being the numerical analysts and mathematicians, B being systems, of which there were very few, and C was AI and related stuff. And so the obvious choice was to do AI. So in the late 60s, I did a dissertation in artificial intelligence. And part of what that involved was writing a program to bid hands at bridge. So I wrote this program, which was actually very good as a bidder. And subsequently, after I graduated, I wrote the play of the hand so that it was a complete bridge program. And I did bring a box, which is the machine that was built. People took my code and rewrote it in machine language. And this is very nice with a little faux leather here and a little wood here. And you open it up and it's got decks of cards and instructions and a push button. And so deep down in there is my code as transformed. And these little goodies sold for $350, which was kind of a lot for a computer game. Don't think they sold very many of them, but it was a cute contribution. So, all right, what did I do after finishing with in Madison?
And when was that?
My PhD was 1970. I left in December 1969 because it was cold in Madison in the winter and better to get a mail order degree. So we came back to the Bay Area. And I had, after a year or two, I ended up joining the faculty at UC San Francisco, which had a master's and PhD program in medical information science. I had a couple of little jobs in between. You had to make sure that you didn't get sent to Vietnam, which wasn't a good time to go. So fortunately, that worked out. And so I joined the medical information science faculty. And
so you might talk a little bit about UCSF, as not everybody knows about UCSF.
Yeah, UCSF is actually one of the top medical schools in the country, or maybe in the world. It was originally San Francisco Medical Center as a extension, as part of the University of California system. And eventually it got its own doctoral programs, and so they gave it a few UC, leveled up to that University of California designation. So they had a graduate school, and the graduate school had biotechnology of various sorts and a couple of other fields, and this medical information science field. In Europe, it was medical informatics. And we had students, a mix. Most of them had medical training of some sort and didn't want to practice medicine. Others came with a computer science background and wanted to apply it, which is really how I came about it, because there were a lot of interesting problems. Certainly at that era, doctors wouldn't go near a computer. I mean, that was something that the staff did. As you look at it, there were all kinds of pretty interesting needs. I mean, just even the idea of transfer and discharge for patients, pharmacy systems to keep track of all the medications and who was on what, and all kinds of things that benefited from storage. The medical record systems of that era were very primitive. Massachusetts General Hospital built a system around the language Mumps, and we could say more about that later. There's a project in Vermont called the Patient-Oriented Medical Record that was in play. Stanford went in a different direction with their medical informatics. They focused on diagnosis. And so there was an AI flavor to what they were doing, which is kind of different from what we were doing. But coming out of that, the thing that struck me was people interacting with computers. I had done a little bit of that in my dissertation because when you bid at Bridge, you have other people out there, and these people were not computer knowledgeable. Hardly anybody was in 1968 and 69. So we would put them at a TTY 33 with yellow rolls of paper. I actually still have some of those printouts somewhere. And so people had to type in their bid. So the whole process of interacting with the computer was an area that I had early experience with. And so looking at medical information science, that was one area, and another area was databases. And of course, the third area was how do you build reliable systems, which kind of migrated me into this whole emerging software engineering field. Again, when you look at the timelines, the NATO conferences on software engineering were in late 1968 and late 1969, and the quality of software at that time and the absence of processes was all quite visible. So in the mid-70s, doing software engineering, it was kind of a new thing, and is a break from computer science, because a lot of computer science had formal grammars, and it had areas that were more theoretical. The exercises on programming, for example. I mean, I admired Edgar Dijkstra, and I even had him as a house guest once for a party, and the work of Tony Hoare and Nicholas Wirth, of course. They were very, very influential to me and to lots of other people. But Hoare and Dijkstra and a few of the others were really much more on the theoretical side, or the small examples that prove. And yet, when you had to build a system for an airline reservation system or for a bank, there was much more of a practical aspect to it. I think that interested me, building, the idea of building applications and seeing them come to life. So that was, it was for me an intellectual driver. Said, how do we architect the system? I was, I think, also influenced by David Parnas, who thought about breaking big things up into small pieces with his work on modularity. I think that was very important. And of course, by 1974, Unix was available, and we had one of the first. We ran Unix at UCSF in our department. I was exposed to it first at Berkeley, because my appointment was funny. It was a full-time UCSF appointment, but the chair of our department said, "Okay, Tony, it's okay if you go teach a course at Berkeley to hang out with the computer science types." So starting in 1970, I did that for almost 20 years, like one course. So kind of keeping my hand in the computer science side of things.
So what did you have, a PDP 1140, 45?
We actually had the first VAX 750 in San Francisco.
Yeah, but that's a little later.
A little later. At Berkeley, the computer graphics lab, which was on campus, had an 1170. So that's what we used on campus. And it was on UCP. You could send mail to it and transfer files and all the stuff that now to us, of course, looks really primitive. But the idea that you could send email to other parts of the world, that was very appealing. So in the mid-70s, I really was doing software engineering, and along with Stockton Gaines, we proposed to ACM to start a special interest group on software engineering. And we got a little bit of pushback from the people in the SIG plan who said, well, you know, programming languages, that's us. And I said, no. So we had but fairly soon that that came to pass. So I'm a co-founder of SIGSoft with Stockton Gaines, and we had a lot of people. It grew very, very quickly, the number of members, and you know, we went through all the ACM formalisms, and we started a newsletter, which of course still exists. And our first editor and our editor for many, many years was Peter Neumann, who did like this fantastic job every time to build up the newsletters, and of course the circulation went with it. So getting into SIGSoft was interesting. I actually have somewhere in this stack the letter that approved SIGSoft and made me the first chair of it. So that of course led us into all the international conferences on software engineering. I was a speaker at the first one.
Where was that?
DC.
Yeah.
It was the first national conference on software engineering. And then in San Francisco, where we met, was the second international conference. There was also an event organized by Barry Baim, which was the International Conference on Reliable Software, which predated both of those. It was in May of 1975 near LA Airport. And that was an interesting event because one of the things that came out of it was the recognition that specifications and requirements are part of software engineering. And some of the early developers said, no, that's not software engineering. You know, it's when we write the code that's software engineering. And you know, my attitude is, writing the code is easy, figuring out what it should do is hard. And so that's
still true.
Still true, absolutely. And you know, I taught a requirements class this fall, and it's still, you know, I've got a bunch of students, and they're all trying to figure out a project, an idea. We kind of emulate a startup, but I'll come back to that later. So here we were in the mid '70s. We had Unix. We had some of the ideas, and I started a project which I called User Software Engineering. And the point of it, the name, of course, says a lot. It is that software engineering, as a lot of the foundational papers said, was about top-down development, architecture of the software. Here's what it's going to do. And my attitude was, hey, you know, there are all these people out there who are going to be using the software, and you have to pay attention to what they need and how they're going to interact with this system, not just, you know, how to architect it from a modularity, top-down design standpoint. So I talked about outside-in design rather than top-down design. And so that kept me busy for quite a few years from a research perspective, the idea of how do you build these kinds of systems. You know, one of the things that I discovered, was that each time you get an advance in the hardware, whether it's performance or a different kind of display or better keyboards or any storage, all of those things let you do more in terms of the engineering options. You have a lot of freedom to do more. So over time, the tools got better. And so that took a few years. But then there was another important transition, I think, which was workstations. So in 1982, Sun Microsystems brought out the the Sun Workstation. They were not first. Apollo was a couple of years ahead of them, and computer vision was a couple of years ahead of them. But those were really being used for CAD, and of course they ran their own operating systems, whereas Sun OS was basically Unix, and not just Unix, but Berkeley Unix. Much to the dismay, I think, of some of the AT&T people who would have liked it to be System 3 or System 5, but it didn't happen. So,
For what it's worth,
yes.
when I was at Bell Labs at that point, our lab actually used Berkeley Unix on a VAX.
Great. So, so here we were, and my connection to Berkeley turned out to be very valuable there, because Berkeley was one of the first places to have Sun workstations, because one of the founders of Sun was Bill Joy, who was a graduate student in the computer science department at Berkeley at the time. So we had this network of Sun workstations known as the planets, and I had master's students working on a project. So we took some of the things that we had done on paper and implemented them with graphical design tools. So we had a state transition diagram editor that we used state transition diagrams to model the interaction. The system does this, they get some input from the user, the system does that. So you could really model it. And so now we had a transition diagram editor, and the transition diagram editor you could animate. So you could actually see what was happening in the dialogue and what was happening, and you could check from a testing perspective that all the paths were covered. All those kinds of things worked really well. So that got us into the whole question of environments. And I think for me, the idea was that a software development environment exists to support a process. And our process was user software engineering, so we wanted a collection of tools that would allow us to do the user interface prototype and architect the system and so on. And so we built the tools to do that, all running on Unix, and as I mentioned, we got a VAX as a gift from Digital Equipment Corporation. Thank you very much. So that came to us at UCSF, and so along with the computer graphics lab, which had also a VAX by that point, we had a Unix community at UCSF. Not as big as the one at Berkeley, of course, but so that kind of carries through a lot of the evolution of my work into software engineering and particularly into software engineering environments.
So now, who were the users of the environment there?
So we did the development. I mean, our students are Berkeley students, and the applications were used by, in the computer graphics lab, of course, there were people who were doing drug design. And so they were looking at molecules and bonding and those kinds of things that were really very well visualized with a big display and the computer. We did some playing around with applications like a pharmacy system or an admission discharge transfer system. The hospital had not adopted any of those things. It was still very much paper-based medical records in paper folders. But certainly there were systems that were being built elsewhere that were forerunners of today's systems. The interesting connection is that one of the most widely used medical record systems today is Epic. And
it's everywhere.
Right. and I went to graduate school with Judy Faulkner.
In Wisconsin, yes.
Right. So Epic to this very day, they stayed private. They didn't go for the whole, launch and growth that you would have expected from a startup. Those were different times. And the other thing that was going on is that Epic was programmed in Mumps. And so there was a community of people who were really big fans of Mumps. And there was a lot of computer science types there. And I got connected to that community because I wanted to see what they were doing, and I wanted to be able to see the applications that were being built. The language is terrible. I mean, it was designed to make optimal use of the machine because it was going to run on a PDP-9, which had very limited memory and didn't process so quickly. So the idea of a compilable language with parsers and the like, that seemed very inefficient. So Mumps is an interpretive language where most of the commands were a single letter. But I got some research funding from our government, the National Institute of Standards and Technology, and a couple of my colleagues and I wrote a series of reports about how to implement Mumps and how to implement its storage structures. And while I remain critical of the language, it was an interesting technical contribution.
Does Epic still use Mumps?
I'm not sure. I mean, I'm an Epic patient, as you are, I suppose.
Yes.
But I have not dug in to figure out what they use. Mumps, of course, got renamed to M. One character. But I haven't been in touch with that community really in 40 years. Because
that suggests a bit of historical research that we maybe need to do here, because Mumps, certainly that history is interesting, given Epic's widespread presence.
Yeah, and I know the people who were there at the beginning, and so if you wanted to pursue that, I could point you to a couple of people who really were there at the outset and could tell you. One of them actually gave up computing and is an author of mystery novels. Yeah, get to change your career. So so all of this stuff was kind of coming together by the mid 1980s. But there was another thing that struck me, which was, I think, a combination of several things in my life. One was my father's own desire to start his own business, which he did in Florida, but it was a failure, like most startups. But the idea of starting a business, and then also in the early '80s, there were a lot of businesses getting started, and certainly that was an age of conglomerates. That was an age where a lot of companies kind of grew up. And I said, well, the software that we were building at UCSF, the transition diagram editor and the database management system to support it, and all those kinds of things, we started writing papers about it and talking about it. And eventually people came to us and said, well, how do we get that? So we said, well, we can distribute it, right? BSD license. So, we talked to the University of California, San Francisco attorneys and showed him what we had in mind and showed him how the BSD distribution worked and signed for it. So we had the user software engineering distribution. And it was a relational database system, and and this rapid prototyping tool and a couple of other things. So great. Now, in that time period, I also had the opportunity to go do a sabbatical, and I chose the Free University in Amsterdam, and that turned out to be a great choice because of the people who were there, and of course the language. Dutch is not easy, but the bus drivers speak English. I mean, it's a country where you can get by with most things in English. Although, of course, the notices that came home from my son's school I had to decode, but I had learned some German over the years, so Dutch, reading Dutch was something I could eventually manage. But I ended up working with faculty there, and I even had a PhD student there. So he built that database system that I was mentioning. So when I got back to San Francisco after the sabbatical, we had this interest in our software, and somebody asked me the question, well, who's going to support it? Because they were going to use it in their company, right? And so that was really an interesting question. And I said, well, we will. So that was what was the initial trigger for me to start Interactive Development Environments, IDE. And that was in the, we started the company in 1983, but there was some other things going on in that period. Of course, software engineering was beginning to grow up, and I was doing more work on software design and on environments. So, and designing a programming language to boot. I actually did some work with Peter Freeman. I mentioned him earlier. He and I put together a workshop on software engineering education in early 1976. We wrote a series of papers, essential elements of software engineering education, proposed curriculum. Dick Fairley was also a participant in the in parts of that work.
Well, Peter and I had a paper in I think in the second international conference, right?
Right. Yes, there was one. That's where it was. So, but Peter and I went around the world and we taught software design techniques. And this is the 4th edition of the book, which was 1983. It kept growing because we thought that there were more design techniques. And in fact, there were. Right? There were techniques like structured design and data flow diagrams that all came up in the late 1970s, SADT, and a whole bunch of other graphical design notations. So that book had a collection of them. The books were fun to put together, and the IEEE was kind enough to publish them. So I did actually a couple more. I did one on programming language design, which has a lot of the classic papers that I was mentioning earlier. And I actually have 2 of these, so I will give one to the museum.
Oh, good, yes. And remember, if there's interesting, unique documents, there is a place here for them.
Good. Well, I have some other, and then I did this one on software development environments. So, what was interesting about environments is most of them were programming environments. So when you look at BASIC, as an early programming environment, and there were some other time-sharing environments where you could get online and write Fortran programs. And then, of course, there were things like Smalltalk 76 and 80, which were very sophisticated environments. There was Interlisp, done at Xerox Palo Alto, but they were all programming environments. And my interest, as you may have gathered, is more about software development environments, the entire sequence of things. So techniques for tracking specifications and requirements and software design architectures, and then, of course, being able to write the code. And that notion is the genesis for what we did with interactive development environments. The idea that we were going to build an integrated tool suite. And again, it was based on Unix to run on the Sun workstation. And we were very influenced by the principles of Unix. So it's an open architecture. The schema for the database was public. The interfaces to the various graphical tools were public, so you could actually add your own symbols if you wanted to. Nobody did, but the capability was there. So, so it's that sequence of things that led to IDE. And IDE built a product family, I should say, called Software Through Pictures. And the idea was that you could graphically represent something and you could generate code from it. So, when you look at today's low-code, no-code systems, they're eons beyond what we were able to do. But, we could take an entity relationship diagram for a relational database and put out SQL, that you could then feed into your favorite relational database system, and it worked. We also did some integrations with programming environments, so this was late in the history of IDE, relatively, and we worked with a desktop publishing tool, Frame, and we worked with a programming environment, it was Sabre Software originally, which was a C programming environment and later a C++ environment. Turns out that the CEO of Sabre Software went on to become the founder and CEO of TripAdvisor. So, interesting thing. So I saved, these are not our original documents, but late in the history we had gotten a little fancier in terms of the books that we published. But here's an information modeling user manual and lots of screenshots, and let you do a couple of different diagram types, because there was some, there was the Bachman camp and the Peter Chen camp. People had different modeling notations. We also supported a bunch of other notations. So there was structure charts, data flow diagrams, and things like that, plus our own transition diagrams. So we had a family of editors. So you could think of Software Through Pictures as a family of editors that supported a variety of software development methods. And the structure charts, because they show the architecture application, you could actually associate code with any one of the boxes or the modules. You could specify the interfaces between modules, and you could export that, and you'd get code skeleton out of it. I mean, if you did everything in the diagram, you could, of course, get everything, but nobody did that. But you could definitely get
So talk about building the company. How many people did you have? Where did you get them? What kind of mix of folks was there? It's sort of not the technical pieces, but all that other stuff. Right.
So, so the company started in my basement, as many companies do. We did some of the original development there. Sun gave us a Sun 1, the original. Because Sun at the time, I mean, this was early in Sun's history, right? Because we started legally in 1983. So by late 1983, Sun gave us a machine that we could use for development. But we really got the machine for a different reason. We had made an agreement with Sun to develop a Unix for Programmers course for their customers. So we, of course, needed the Sun workstation to develop the course. And having a machine sitting in the basement meant that we could use it for our other purposes too. Somewhere in this folder I have a copy of the check from Sun that was our first work, but I also have, we were one of Sun's first independent software vendors. And they published a book, right, a catalog. So this is the flyer for our software from Sun. IDE, software through pictures, case environment for Sun workstations. So Sun was our first customer for the Unix for Programmers course. And then in terms of putting a team together, the team was one of my graduate students, and who had done a lot of the prototyping work for his dissertation. He's no longer with us, unfortunately. Another key person was Peter Percher, who was a doctorate from the University of Zurich. And because of my various connections, he came and did a postdoc. And his postdoc involved writing a lot of this code for the prototyping system. And the student whose work I supervised in Amsterdam had the lead on writing the database management system that we used. So student and postdoc labor got us started, which is, I think, is not all that uncommon for startups, certainly at that time. And my wife took care of all the administrative stuff. That turned out to be valuable because at some point you need HR and the like. So we got the software built, and eventually we decided that it was time to move out of the basement. You can do just so many customer presentations in your basement. We did one, actually. And then we also showed our software at trade events. So in late 1984, we went to the Sun User Group conference, and in Boston on Election Day in 1984. So this was the day that Reagan was reelected. A lot of people came and looked at our stuff, and they said, "Oh, this is cool. What does it do?" So being at a general Sun event wasn't quite our target market. But in early 1985, we went to a couple of real Unix Expo kinds of shows, and that was a little closer because there really weren't any software engineering trade shows at that point. But we got a couple of our first customers from that, and one of them was EDS, Electronic Data Systems, which this was Ross Perot, and it was a very important consulting company, and they were going to use software through pictures internally to do the design of things for their customers. So that was our core, and it was time to grow up and get out of the basement. So we found a sublet of a business in downtown San Francisco. In fact, it's in a building that got demolished because the Moscone East building is there now. Moscone Convention Center in downtown San Francisco. But we had space, and so we hired somebody to be our office admin and do some of the initial financial P&L things. We had a place for our Sun computers, so there we had grown up. And we were still 6 or 7 people. We hired one guy as a salesperson, and he was okay. And by the time we got to 12 people, what happened was that we had contact in the UK. And so he wanted to be able to represent us, his company. And we said, why not? Well, we got this huge lesson, right? Because the laws in the UK are completely different and you had to incorporate over there. And so he had to do all this kind of stuff. But here we were 13 people and we were a multinational. So that was kind of fun. And he did okay. We lived with the 8-hour time difference. So there we were. And with a dozen people, we were then, like any other company, we were then looking for funding. And in spring of 1988, we had been talking to Mayfield Fund here in the Valley, and the partner there was interested in funding us. And we also had...
Which partner was it?
Norm Fogelsong, who left Mayfield shortly after funding us. And there's a long story there, but we ended up with eventually a third partner. So that was not entirely a successful relationship. The other part of the relationship, the other half of our venture money, came from corporate funds from Thomson, the French conglomerate. We were introduced to them by our French distributor. We had made arrangements in France for a distributor, and they had a good connection, and so we ended up taking a venture investment from the two of them, which got us to the next phase, so we could have somebody who had significant marketing experience. We had hired earlier a senior salesperson who came out of the CAD business, but who was much more experienced at sales than any of us. He knew how to put together a sales team and how to hire people and how to set up territories and compensation plans and all the kinds of things that they don't teach you in a computer science graduate program. So Chuck was very helpful for doing that. And one thing that he did that was tremendously valuable, he looked at the rest of us, the founders, and said, well, you don't know anything about sales. What you need is sales training. So, now that we were newly funded, we said, sure. And so we had sales training. And the sales training is a very well-known firm, at least it was at the time, was Miller Hyman. And they had a book, about sales strategy. And we learned a lot about how salespeople work and how they qualify customers and how they close the deal. And I have to say that was one of the most valuable weeks of my life, because you're always selling. It's not just I'm selling my product, it's I'm selling my idea, I'm trying to convince somebody. But of course it was very valuable to us understanding how to grow the company. And one other lesson that came to me from that, which has served me well, is that the salespeople, whoever you hire, they're the face of the company. So they're in trade show booths, they're calling on customers, and people buy from people. So for the whole time, I would always interview sales candidates in addition to, all the sales discussions that they had. You ask yourself, is this a person that you'd want to have lunch with, for example? And so I think that interviewing the salespeople was maybe a bit much, but it was very useful. I can't say that my choices were always right. And it was very uncommon for me to recommend against hiring somebody maybe a couple of times in all those years. But the message that you're important to us, you're the face of the company, it's important that you keep that in mind, and it goes beyond closing the deal. It's building a relationship with that customer over time. So that was again a very useful thing to do. So we had a product that was a good product, and people bought it. The price was ridiculous compared to what people pay for software development tools today. It was about $8,000 for a seat, and that was in line for the time, but an order of magnitude high by today at least. But a couple of other things happened. One is that we ended up talking to a company that loved our product, but they had rooms full of Apollo workstations. And so they wanted us to port it to the Apollo workstation. And we did. And we won the deal. So that was a big win for us, because they were a leading company in the aerospace and defense industry, and they were willing to be a reference. And Apollo was happy with us, Sun less so, but Sun was great to us. I mean, I really have nothing but positive thoughts about Sun. One of the things that really worked well with Sun is that apart from the usual things that third-party vendors get, early access to software and machines and the like, they realized that when people bought our product, they almost always bought a Sun workstation to go with it. And so the salespeople were gung-ho on this. They said, oh yeah. So we had access to every Sun office everywhere. And I mean, it really went a long way. In 1986, I was invited to speak at a conference in China. And, China wasn't very far along at that point. It was not easy to get there and not easy to travel around. But it turned out that there was a distributor that had a grand total of 5 Sun workstations in all of China. And we got one to use for a demo of our product there. Thank you, Sun Microsystems. The same thing happened to us in Italy, talking about environments. The Italian government decided that they wanted to help develop the south of Italy, which is, of course, much less developed and more agricultural than the north. Then and now, for that matter. So they gave money to a company in the north just to put on an event in the south, right, as a way to attract interest from the south. Well, okay. Where did they put it? They put it on the Isle of Capri, which, it's part of Napoli, so it's the south. And then we were able to get a Sun workstation by boat from the mainland to come over to use in this. It's actually a convent or a monastery where they held this conference. So here we were with a Sun workstation in the middle of this 15th century monastery. It was great. But thank you again, Sun Microsystems. So these are some of the things that you remember above and beyond the various individual deals that you do. It's building up the relationships and building the company. So eventually, we ended up with distributors in lots of places. we ended up with a Japanese translation of the product, which took some work, probably didn't justify in sales the revenue that we got from it. And we had distributors in most of the Western European countries and in Australia and in Canada. But we eventually had grown enough in a couple of countries that we could open our own offices. So we worked with our French distributor to go direct in France, and we worked with our German distributor to go direct in Germany. By the early 1990s, we had a bunch of people in the US, of course, and then we had subsidiaries in England and France and Germany, and we put our European headquarters in France, which was a less common choice. A lot of American software companies put their European headquarters in the UK or in the Netherlands. To me, the UK wasn't Europe. And that, of course, has turned out to be true. So our headquarters were on the industrial side of Versailles, nowhere close to the palace. But we had a team over there. So we got to that point, and we were close to 200 people, which is pretty good size software company.
Pretty good size software company, yeah.
Right, and then, but what happened was, of course, there was a blip in the economy in the late 80s and early 90s, and then Windows happened. And so once you were away from the high-tech aerospace and defense and computer-aided design spaces, Windows very quickly took a major place on desktops in corporations, and we were late to the game there. We eventually had a Windows product, but that kind of flattened us out, and our investors decided that they would bring together, merge some of the companies in which they had invested. So Thomson had invested in 3 software companies in the US, and they put us all together and called it Aonix, A-O-N-I-X. And it's sort of like taking apples, bananas, and oranges and calling it fruit, because the 3 companies had relatively little technical overlap. And of course, that signaled that it was time for me to leave. But we got to that point. One of the funny outcome is that Aonix was then sold, and then the company that owned it then decided that they were going to give away, they'd renamed Software Through Pictures, and they were going to give it away. So the people who were in our German subsidiary got it, and I can't say that it's open source because it doesn't have an approved open source license. But you can go download the code from OpenAmeos, A-M-E-O-S, and there's all that code. And, you know, it's C code written in 1988. You know, some of the people who wrote it are still around. And they, you know, if you're managing software developers, one of the guidelines you give them sometimes is, you know, write this code as if you're going to show it to the world. And that turned out, of course, to be the case here. So there actually is still a Windows version of OpenAmeos, which does a lot of what Software Through Pictures does and had the same kind of look and feel, but it's Windows product. So old software never dies. So that kind of takes us through the IDE adventure, and it was great. I mean, the idea of being on the industry side and being understanding what it actually takes, not to write the software, but to build the product and to support it and to deal with platform updates and user requests and all the other things that come into the roadmap and the evolution of a product. We were still back in the days where you had to ship media to customers. So if you goofed on your development, you got to make a whole lot more tapes and send them out again.
And ship paper documents.
And ship paper documents like these guys, right? So, of course, my stint at running IDE ended in June of 93, 93, sorry, 93. And that, of course, was at a time when FTP had become available and people were starting to use the internet. We were, I think, one of the first companies, if not the first, to publish an email address in an ad. This was in 1985 or 6. And, so people actually contacted us by email. It was quite amazing. We also became, in 1987, one of the first 100 .coms. So if you go and you look at the list of the first 100 .coms, there we were number 78 in June of 87. So there was an interesting transition going on, but we were, of course, with a website by 94, 95, relatively early for this. But it didn't have the kind of flavor that today's websites do. I mean, if you design a website today, it's got much more of the call to action kind of elements to it.
Now, you'd mentioned an acronym earlier that I, of course, knew. I can't remember when they came as CASE.
Computer-aided software engineering.
Yes.
Yes.
And I don't remember exactly when that started to get used and how long it sort of lasted.
Yeah. So it got, I think it was kind of in the late 1980s because there were companies like Intersolve in Cambridge, Massachusetts, and there was the former Minnesota Vikings quarterback, Fran Tarkenton, was the chair or the CEO of a company called KnowledgeWare, which turned out to be not a viable company eventually, but they had gone public and all. Texas Instruments had put something together, and then IBM took a very important role because they came up with the idea of a repository and a computer-aided software engineering environment where all these third parties could sign up to be part of their environment. And of course, that cost you some money. And it ran not on Unix, but on their mainframe. So we never joined in on that, but this was called AD Cycle, Analysis Design / Cycle. And AD Cycle got a whole lot of press and not much reality. But this was in that era in the late 80s, early 90s. So there was some of the press, wrote about this, and they talked about vaporware. Does computer-aided software engineering ever actually do anything? And I thought that we did something. Some of the other products, and we had a couple of direct competitors. They did something too, but not everybody. And there certainly was a hype cycle around it. So it kind of fell back in the way that these things do. So, but computer-aided software engineering is around today. Nobody really uses that term. They just talk about development. And I think that there was a period with notations that people draw structure charts and ER diagrams and the like, and it ended up with something called UML. It's the Unified Modeling Language. And the Unified Modeling Language was kind of the kitchen sink of modeling notations. There were three people who took the lead on putting it together. One of them, Grady Booch, is known, and Ivar Jakobsen is known, and Jim Rumbaugh is known. So they came from their respective companies and created the UML, and it's not very widely used. And that was in the late 90s. But again, if you go back and you look at the last versions of Software Through Pictures, there was an implementation for some of the UML notations. So that's there. But so, people don't think as much about graphical development environments now as they did. It was much more of a development and prototyping and agile approaches that, of course, first came into play in the early part of this century and have now really taken a stronghold in terms of development processes in small companies and startups, not so much in legacy. So there's a lot going on, right? So
a lot going on, yeah, and software engineering in that time,
right.
yeah.
So half my career in academia, half my career in a startup, in my own startup, but here we are in the late 1990s, and that's a time of the first dot-com boom. Right. So everybody with an idea was able to get funding and to go forward with it. And so after I left IDE, I was advising a startup in San Francisco, and it's a perfectly good idea. The idea was auctions of used cars, but not just any used cars, but inspected used cars. So the company went out and got some vans and equipped them with all the things that you need to be able to do an on-site inspection and test of a vehicle, hired some knowledgeable mechanics and supervisors. So the idea was a marketplace for inspected used cars, and it was called Best Offer. Best Offer came into being very shortly before eBay Motors came along. So it was very clear to me fairly early on that it wasn't going to be a success. But there was one very valuable aspect to it, which was the technology being used was Java Enterprise Edition, J2EE at the time. And so this was an opportunity for me to learn J2EE, which was at that time still pretty fragile. The idea of getting a phone call in the middle of the night to bring the site back up was pretty common, but the traffic to the site was pretty low, so that I don't expect anybody much noticed when it went down at 3 in the morning, but it was back up. So when that went away, I was looking for something else, and I found this great small company, Bluestone Software. And Bluestone built a J2EE app server. Okay. So there were 3 or 4 companies that built them. BEA was perhaps the best known of them. IBM had one that they built in the Toronto lab, and Bluestone, and then there were 1 or 2 others, but JBoss is worth mentioning. So 4 significant ones, and So I got hired to open a West Coast development lab. The company was based in South Jersey. So you flew into Philly. But it's fair to say that Bluestone Software was the best high-tech company for 40 miles in any direction. So I got to go back and visit them every 6 weeks or so. But what happened for me is that the guy who hired me said, Tony, go do mobile. And this was in 2000. So in the United States in 2000, the penetration of mobile was not very significant. And of course, having mobile devices talk to a Java app server, that was an interesting challenge because you didn't have HTML talking to phones at that point. You had a different ML, and so that meant that you had to do some on-the-fly translation. And of course, the input from your device to the app server also was a bit of a challenge. So we used the state-of-the-art technology at the time, model view controller architecture, and we went off to the UK to buy phones, which was great. The phones we all bought were the same ones that Neo used in The Matrix. So here's my Nokia phone. I probably still have it. And we had a customer. And so our first customer was Swisscom. And they were going to put it into production use. They wanted the software and they were going to equip hundreds or thousands of phones with it. So it was a real build this product, ship it to customers, which is what I always liked. It was always great for me. So here we were, and on the line to deliver. And the engineer who was the lead on the project got on a plane the night before we were supposed to deliver it, flew to Zurich, and delivered the software and installed it. And we did we made our delivery. But Bluestone was really a great little company. They had gone public shortly before I joined them. And of course, they suffered like everybody else did with the dot-com bust. Even though they were past the dot-com stage, the tech stocks in the 2000, from March 2000 down into 2002 was kind of like the nuclear winter for software startups. So HP acquired Bluestone, and that was not a marriage made in heaven. Without going into too many details, Carly Fiorina was HP's CEO at the time, and they acquired Bluestone for, I think, a reasonable amount of money, I guess. Those of us, some of us had equity a little bit, but HP didn't know what to do with us. Middleware, what's that? And their salespeople were already selling BEA. So, here's this other product. Well, we know how to sell that one. And we were making our numbers and so on. So they never had much success selling our product. So they made it free at some point. And then, of course, HP got occupied with the Compaq merger. And so eventually they decided that, gee, they're really not a software company. We're certainly not in the middleware business. So they got rid of the whole middleware division in August of 2002. So I lost the bet because I had bet that we would survive a year, and we survived 19 months. So one of my colleagues won that bet. But So that went away, and I spent a little bit of time as I guess my title was VP of Product Development for a company that was trying to take natural language, people speaking software requirements, and turn it into use case diagrams, a notation developed by Ivar Jakobsen and also part of the UML notation. And it was a tiny company without much funding. It had a seed round of funding. It was over in Berkeley. And they didn't get over the hump. They survived for a while. I stayed less than a year. But what happened next was interesting. I went to, I was looking for something to keep me occupied, and I went to the International Conference on Software Engineering in Edinburgh in the spring of 2004. And so one of the people who was there was Martin Griss, whom you may know. Martin Griss, I had known for a long time, and we had done a couple of things together. When I became part of HP in the Bluestone acquisition, Martin was running HP's research lab. So we were in the same building. We saw each other from time to time. And so Martin was in Edinburgh, and he said, oh, you know, I've been going over to Amesfield because Carnegie Mellon is starting a campus out here. And why don't you come and visit and see what we're doing? So, great. And when I went, it was still in a very early state, but they were teaching a few courses at Ames, and some students were remote. But I signed on to assist with one of the courses, and then a year later, I was offered a full-time position, and this was in 2005, actually. My full-time position started in June 2005. One of the things that I said very early on was we're dealing with startups. You know, Silicon Valley doesn't build software the way that the Carnegie Mellon Software Engineering Institute thinks software gets built, because the SEI's clients are aerospace and defense companies that have product life cycles that last a decade or more, and they have huge embedded systems needs, and they have reliability needs that, you know, you can't put up an untested aircraft. The software has to be tested. So I advocated very strongly for putting together a curriculum that was aimed at Silicon Valley. I mean, here we are, right? That led to the creation of our Masters in Software Management, which came into being in 2007. And I was offered actually I became the first director, and I decided, no, I didn't want to be the director. That was too much bureaucracy, too many trips to Pittsburgh. One of the instructors had been there long before me. She was there at the outset, and she's great at this kind of thing. And so she became director in that era and remains so.
Who's that?
Gladys Mercier. So she is the director of the software management program. And I'm just, you know, a professor. So the courses I taught, eventually they evolved a bit because it took a little bit of time to figure out exactly what people need, because some of our students who are from larger companies, and some were from relatively small companies. But when you're charging full tuition, you get students who come from Google and Oracle and Adobe and well-established companies. We always had the program initially was for part-time students, and we always had remote students. So we were ready for the pandemic because we had been teaching remote students since 2004. And the technology for reaching them, communicating with them had improved over time from, phones and speakers in the ceiling to video. But we were definitely, all of us on the faculty, totally prepared to teach our classes remotely, and many of the students, of course, as well. So the part-time program revved up, and Martin Griss was the head of the campus after Jim Morris left. Jim Morris was the first head of the campus, and he's very well known for being one of the leaders of computer science at CMU in Pittsburgh. And so he came out to run the program, which was actually started by Raj Reddy, who is, of course, very famous. And Raj Reddy started the program because he's friends with Vinod Khosla, the founder of Sun. And so Vinod said to Raj, hey, you got to be out here. So for me, this was great. It's right, Sun meets software engineering, meets startups, meets Carnegie Mellon.
So why don't you talk about the courses as you've been teaching them the last few years, and sort of how they got there, if they've changed a bunch.
Right, good. So the first years, as I said, we had part-time students. And one of the things that happened in, maybe 2009 or so, we had originally come up with our own product ideas for students to work on. Said, okay, now you go through and you analyze this and you design that and so on. Nobody ever had to write any code. But they went through the analysis and design process. And then in 2009 or so, one of our students said, hey, can we work on our own idea? And we talked about it as a faculty and said, sure. And that was an important step, because subsequently we said, why, if we're going to be like a startup, then let everybody work on their own startups. Let people come in with their startup ideas. Let them team up as appropriate. So from 2009, 2010, people were expected to come up with their own idea. And of course, we had a few other ideas in our back pockets in case somebody really got stuck, but we never had to use them. And a couple of years later, Pittsburgh is looking at us as a financial potential source of revenue, and we didn't have enough part-time students. I think it's probably a marketing problem, but they said, well, let's admit full-time students. Let's have a full-time program, and so maybe 2011 or 12, somewhere in there, we started admitting full-time students. And as with most tech graduate programs in computer science, software engineering, most of them came from India and China. But they still had this challenge of coming up with their own idea. So a few things have happened. The main thing is the courses have evolved a little bit because it's much more emulating a startup in a university. Everything but the code. So you come in, you have your own idea, you form teams, you go out there and follow. We use the Startup Owner's Manual as one of the books that people read. That's Steve Blank, and that's he had previously written 4 Steps to the Epiphany. So the students have to go out and identify a pain point that people have, and then come up with, do some interviews and come up with some potential solutions and work through all the things that any startup is supposed to do. Understand the target market, define personas, and eventually come up with a proposal for a product idea, go validate that with people that they've interviewed before or with new people. So they're doing all the kinds of things that you expect from a startup. And they have to do competitive analysis. If they're going to build a job search application, they have to go out and say, well, who are you up against? Do you have this all to yourself, or does somebody else own 90% of the space? So that turns out to be an interesting exercise, in part because they see what it takes to build a startup, and in doing so, they see that 90% of startups fail, and they begin to understand why. Funding and getting the product idea not quite right, a lot of competitive space, all those kinds of things come into play. And I tell the students, on any given day, you can pivot. You get up in the morning and somebody's done something different or introduced a new product, or you don't think that you can generate enough customers from this, pick something else, switch, because that's what everybody does, right? And that's gone pretty well. And at the moment, I'm teaching about 45 students, and there are 10 projects. And I think there's maybe one of the 10 that has a really good chance of being successful if they were to continue it beyond their time in the university. And of course, the university has its own programs for incubation and the like, so that they could go on and join an accelerator and get funded and the like. So all those things come into play, and people have to get up and make their pitch. One of them is a launch pitch, which is, here we're announcing our product, here's what it does. Another is a funding and investment pitch. So it takes 2 full semesters. So, and I teach the first semester and half of the second one. So there, at this point, I'm teaching a software product strategy class, which is really a breakthrough for these students, because it's mostly about, one, estimating how long it's going to take you to build your product. And of course, even experienced software engineers tend not to be very good at estimating. And so when you try to estimate a big project for the first time, breaking it down into pieces and parts, that's a challenge. Even when I tell them that I don't expect that they're going to get it right, there's a lot there. So the next task, the one they're just starting, is to create a marketing plan. And this is completely alien. Completely alien, because, who's my target market? How am I going to reach them? Am I going to do outbound marketing, direct mail and magazine advertising and trade shows and the like? Or am I going to do inbound marketing with search engine optimization and the like? Am I going to do online advertising? Am I going to buy a Super Bowl ad, which of course is on people's mind this week? But I said, no, you're not buying a Super Bowl. Target market for Super Bowl viewers is different, right? If you're selling beer, then you buy a Super Bowl hat. So they have to create a press release. They have to create a website. They have to do several of the things that you would associate with marketing, and they have to decide how they're going to spend their money. Right? There are, do you want a billboard on Highway 101? Do you want somebody sitting halfway around the world making phone calls to prospective customers? There are all kinds of ways that you can do it. And then, so they're incurring costs, right, for engineering and for marketing. So part 3 is to estimate sales. What's your price going to be? Who's going to buy it? How long is it going to take them to buy it? What kind of a sales team do you need? Can you sell it online? Can you sell it through an app store? Or do you need to have some sales team go out and make a presentation to an enterprise customer, which takes a while and costs a lot of money? But what comes up, of course, they haven't seen this yet, but they'll see it in a couple of weeks. You want the sales to exceed the expenses for marketing and engineering. Right? You can take other people's money, and that'll work for a while, but at some point, your business has to be cash flow positive. Otherwise, you pack up and go home. So that's where we are, and it's fun to teach. Because I didn't know any of the sales and marketing stuff when I started out, so I really can put myself in their shoes and struggle with how am I going to reach the people I need to reach? Am I trying to reach a particular market segment, and if so, what websites do they visit? What shows do they watch? Whatever your mechanism is going to be. So that goes on, and the other course I teach is called First Time Manager. And again, it's an interesting follow-on to being a software engineer, because if you look at a software engineering curriculum, it turns you into a great individual contributor. Okay. But how many years is a software engineer going to want to stay there and just write code? Some want to stay forever. That's great. More power to them. But a lot of them don't. And so in the first category, the ones I was just talking about, they want to become product managers. Maybe their technical skills let them be technical product managers, but they're out there interacting with customers and with engineering, because the job of a product manager is to be pushed and pulled in all directions by management, by customers, by engineering, to try to get to a happy medium where you displease everybody about the same amount. So that's a path for people who don't want to stay on the technical track. And even to be a CTO, you have to understand a lot of the technology usage, not just the development process. Then we have this First Time Manager course where, again, we kind of play act certain parts of it. Here you are on day one, you're now a manager, and you have 6 direct reports. Introduce yourself. And we go from there, and by the end of the first week of class, I've asked the students to describe what it is they're going to do on day 1, week 1, month 1, quarter 1, and they begin to see what goes on. And again, it's a fun course to teach, because the lesson at the end is some people say, gee, I don't want to be a manager. I don't want to deal with the HR department. I don't want to interview all these candidates. Recruiting is a pain. And dismissing people is not something I want to do. It's a touch of reality.
Yeah, I'm eternally thankful that my first time management was in Bell Labs. which had very good management training. Particularly compared to Silicon Valley, which is less disciplined.
Right, because I mean, there are established companies that have good management training, and these are companies that have been here a long time and they're very well established, and they've put all these processes in place long before the internet.
Yeah.
So, and I can't speak to how things work in the others because I haven't been there. But yeah, so that's what I do. And the other thing that I have done, and I didn't talk about at all, really is open source software. Yeah. So when I joined Carnegie Mellon, initially there was some room for doing research. The campus is not very research focused now, but in talking to Martin Griss, we came up with the idea that this is an interesting and emerging area of open source software. So if you go back and you look, we released our software from the University of California under a BSD license in 1980. So I've been doing open source software for all those years. And of course, when we started IDE, the BSD license allowed us to make it proprietary, and we made it proprietary but open. But you couldn't have the source code. And when I went to Carnegie Mellon, the field of open source software, it was in this kind of intermediate state because the open source definition had been approved, the open source initiative had been created, there were some well-established pieces of open source software like the MySQL database and the HTTP server, which had been the basis for Apache Foundation. There was Linux, of course, which had driven a lot of this, and the Linux Foundation came later, but there were some other groups, the Free Software Group and the like, around. So, but open source in the 2005 era was really two camps, right? It is, on the one side is, we don't do open source, and the other side was, we don't buy proprietary software. So, and of course, the bad guy in all of this was Microsoft. And Microsoft CEO at the time was Steve Ballmer, and he said things like, well, like open source is a cancer, and open source is a communist plot. So that really was, a message that had to be overcome. But it got overcome in a variety of ways. One is because there was just more and more good quality software being built and made available, and initially on SourceForge, later on GitHub as SourceForge deteriorated. You get, and then you had the economic turndown in 2008, and a lot of companies still had software that they wanted to build, but their budgets got cut. And say, what about this open source stuff? And so they would discover that, gee, it mostly worked well most of the time, and they had access to the source code. They didn't have, at the time, of course, much access to support. And the whole idea of discussion forums is very different from calling some toll-free number and speaking to some support engineer. So there was a very definite gap in there. The area where I focused my work, starting in 2005 or so, was evaluation, adoption, and use of open source software. And that came about in part because of a startup called SpikeSource. And SpikeSource, the CEO of it was Kim Palesi. who's was the first product manager for Java. So she's been around for a while, and so a couple of people from SpikeSource and some funding from Intel, and some support from O'Reilly, and me. So 4 organizations represented, and the idea of SpikeSource was to talk about something called the business readiness rating. And the idea was you could look at a piece of software, open source software, you could evaluate it, in terms of is there support for it, is there documentation, how widely used is it, and you could literally calculate a score for it. And so that was the original idea of the business readiness rating. The score turned out not to be all that significant because you could pretty much tell who was using what, and so you could see what was going on. But what happened, unfortunately, was that SpikeSource didn't survive. Intel had other things on their mind. The guy who was working with us from O'Reilly went home to New Zealand, and so the business readiness rating kind of made it to 2006 or 7, but not much beyond. And it sat there without much happening for a while. And then a few years later, I had some students who wanted to do a project. We brought it back to life, but we gave it a very different flavor. And we didn't call it that. We called it OSS PAL, Open Source Software PAL. And PAL is a double meaning because the person at SpikeSource who had worked with us was Murugan Pal, and he got sick and died. So OSS PAL as a name is an homage, as well as having the meaning that this is a PAL for your open source software. So we took a different approach, which was to curate open source software. We worked with IDC, the International Data Corporation, which is, of course, an industry analyst. They produced every year a software taxonomy, where they took software and broke it into 80 some odd different categories. And so we said, gee, that's an interesting breakdown. And we thought about taking open source software and evaluating it in each of these categories. And that worked okay, except that IDC didn't spend much effort on development tools. And of course, development tools were the strength of open source, all the infrastructure and development tools. Right? There's a very clear philosophy, right, which says, I don't want to spend my time rebuilding the infrastructure. I want to build my startup, and write the value-added code, the things that make people want to buy and use my services. So infrastructure software came first, and IDC's taxonomy didn't serve it all that well. But we pushed ahead and we built a website called osspal.org. It's inactive at this point, but as recently as a couple of years ago, pre-pandemic, it was up and running and had hundreds of open source projects categorized in there, and there's people could evaluate it the same way they could evaluate a movie or a restaurant or a travel agent. So 4 or 5 categories that were general on a 5-star basis, and 4 or 5 categories that were specific to their category, and people could write a free-form review and so on. So that was what I really worked on with open source software.
Well, that's certainly come a long way from when I was first involved with it was actually in Share. Okay.
Ah, yes.
Okay, in the early 70s.
Share and Guide.
Yeah.
Yeah, and yeah. Deakus from DEC. Yeah.
Yeah, and of course there was also the DEC user tape at that point.
Well, that's Deakus.
Pardon?
Decus,
Decus, yeah,
yeah.
Decus, yeah. And there certainly took a very different form, but I always found it interesting how much sharing went on sort of underneath the table.
Absolutely, but there were no licenses whatsoever.
Yeah,
It's here's the code. Do with it what you will.
Yes.
But yeah, now what's happened, of course, is that there's been a lot of investment in open source. There are VCs who funded it. There are, certainly venture funders noticed that Sun acquired MySQL for $1 billion, and that Oracle acquired JBoss for something like $350 million. So there's been a big jump in commercial open source software. I wrote a paper in 2006 called Building a Business on Open Source Software. And there's, of course, been a tremendous proliferation of what's called commercial open source software, and a lot of funding going into it, all using the model that there's a core that's open source and there's some additional stuff that isn't. And so that isn't strictly open source. It gets into this whole lengthy political discussion. But you had some other things going on that have made open source much more noticeable and successful. When Satya Nadella came and replaced Steve Ballmer, you had a completely different attitude about open source software. And then, of course, what did they do? They went out and they acquired GitHub.
GitHub, yes.
For $7.5 billion. And Satya Nadella was quoted as saying, "We're all in on open source."
A big change.
Big change. And of course, IBM went out and spent $34 billion in equity to acquire Red Hat. So Linux has gone from being Linus Torvalds' plaything in 1991 and 2 as a student in Finland to being this multi-billion-dollar business, of which Red Hat is the largest piece. And you have all of these open source foundations, Mozilla as being well known, Linux Foundation, Apache, and even the languages now. There's the Rust Foundation and the like. So open source has taken a really significant space. People ask me if I think they're going to rule the world, and I think that that's unlikely because there's a lot of commercial and proprietary software, and there's these companies that are half and half. So I try to get people to pay attention to open source, and I do teach an open source class where we talk about licenses and some of the business aspects, as well as the most recent things going on in open source mirror what's going on with proprietary software, which is software bill of materials, cybersecurity, and these are, of course, important in all aspects of software. So yeah, it's become a big thing. I was one of the people who joined early on. Not everybody knows about IFIP, but IFIP is the International Federation of Information Processing, and it was started in 1960. And it was a federation, which meant that every country could send their top IT organization, so ACM and IEEE, and then IFIP gets its work done by a bunch of technical committees, and each technical committee has a bunch of working groups. And so one of them was devoted long ago, back in the 1970s, I was an early member of design and implementation of information systems. And I'm still a member, in fact. and they run an annual conference. But in 2006, I joined very early the Open Source Systems group, and again, it runs an annual conference. I have this is the proceedings from 2009, so it's commercially published, and I'm one of the 4 editors of this because I was general chair of the conference. So there's a whole series of these things, and in 2015, I became chair of the group, and you're normally supposed to be chair for 3 years with 1 re-election allowed, but then there was the pandemic. So I was the chair from 2015 until 2022. So it's moved on to other hands now, but of course I'll still be involved in that.
So what's ahead?
Well, that's a good question. As you can tell, I like doing stuff. I'm not likely to sit at home or to go out and play golf every day. I've played 1 round of golf in my life, and that was because my boss at Bluestone Software insisted that we all go out and have a round of golf and play around the golf. But one of the other things I do is I'm an advisor in Berkeley's Skydeck program. So Skydeck is an accelerator started out of the Haas School of Business at Berkeley, and so almost all of the advisors, and there are like 400 of them, are connected one way or another to Berkeley, and all the projects that come in that get proposed have some kind of loose connection to Berkeley. And so there's a matchmaking deal where the companies that get selected get to choose their advisors, and the advisors get to choose their companies. So I think that that's interesting. And they have 1 tier of companies that are just about ready to go out and look for venture capital money. They've got a product in the market or close to it. And then there's a 2nd tier of companies that are not that far along, but which might come along and be in that 2nd pool the next time. So I'm advising a couple of companies there, and I expect to continue with that. The other thing is I'd like to get back on an airplane and go to some of these conferences, and also to do some traveling. I've had the good fortune of going to 75 countries or so. The count isn't exact because you don't know quite how to count the Soviet Union or East Germany.
What's Hong Kong? Yeah, right.
Yeah, exactly. But somewhere in that ballpark. And I like doing photography, and I have a Flickr site that has something like 6,200 photos on it going back to 2005. Well, actually, some of the photos are older because I digitized them. I have a photo out there of East German soldiers in their traditional boot marching. So I hope to do a bit more travel and keep involved here and there. This is going to be my last year at Carnegie Mellon, and that's I've been there 18 years. It's good. It's
a long time.
Yeah, it is, and so going off and find something.
So maybe one last thing, I think, or one next to last anyway. Maybe philosophize a little bit about the interaction, distinctions, overlap between computer science and software engineering, sort of historically and now, how do those fit together? Yeah.
So, and they do fit. They're not 2 separate camps, because people who come into software engineering, they expect to build stuff, right, or to analyze stuff. I mean, they're really hands-on people. And one of the early discussions that went on in the days of software engineering was that the word engineering is a hot button. And that in some places, if you call your program engineering, you better go out and become a professional engineer. You have to take a test and get licensed, and of course keep up and be relicensed over the years. So when we were first starting to put out, these papers about software engineering education, and the topics that we listed back there included management and communication skills, and things that really mean that you're talking to your customer, or you're managing a team of people, or you're managing a project. These are things that you didn't find in software engineering or in computer science curricula. And so, again, if you go back to the 1970s, you had previously the NATO workshops on software engineering. You had the beginning of the software engineering conferences that you had an IEEE Technical Committee on Software Engineering, and you had ACM, Special Interest Committee on Software Engineering, both 1975-76. You had the Transactions on Software Engineering as an academic journal. So software engineering began to separate out by creating its own publications and curricula and definitions in that time frame. And what that led to over some years was things like the software engineering body of knowledge. And the body of knowledge for software engineer, of course, includes a lot of software engineering principles, because you have to be able to use abstraction and modularity and write code in one or another programming language and test to see that things are right and do analysis and design. So all those things come over from computer science. Well, maybe analysis and design, not so much, but there was a little bit of conflict as people tried to establish software engineering departments. And it's pretty well sorted out now, but a lot of software engineering programs are in an engineering school, and a lot of things like computer science, they may be in arts and sciences. And you have a number of programs that kind of are down the middle, right? There's a product management program in the School of Computer Science at Carnegie Mellon in Pittsburgh. There's the whole School of Informatics at UC Irvine, which had a very significant software engineering faculty early on, because I was working with Peter Freeman there in the 1970s, and we were doing
some papers with Nancy Levison too, as I recall.
Nancy was at UCLA.
Oh, yeah.
Yeah. So Dan Barry and Jerry Estrin were the faculty there. But here, Peter Freeman and I did this. Yeah, another plug for the book. Long out of print. But so I think that people who want to build things gravitate toward software engineering. And that's not to say that, there are people who design programming languages and design database systems. And that's really computer science. But then when they want to apply them and build a system, then it's not theory, it's practice. And it's that theory-practice line that it's a gray area. I mean, because there is quite a bit of practice on the computer science side, but the management and analysis and design and some of these things, the techniques that it takes to create a website like Amazon or Google that have hundreds of thousands of servers and reliability constraints that are unbelievable. Those are things that really represent, in my thinking, a really outstanding job of engineering. It's very hard to go back to where we started and imagine those kinds of systems. They're just spectacular. Netflix the same way. The amount of data that flows when you're streaming video, it's like numbers that you couldn't begin to believe when you were playing with floppy disks.
So anything we haven't talked about that we missed that you should cover?
Probably, but I think that we covered many of the topics. That it's not a well-defined path. I think that's one of the things that always comes up. It's students will come to you and say, "Well, how did you end up here?" And they say, and your answer is, "Well, how much time do you have?" Because there's a lot to it, and you meet a certain person, that person's influential and pushes you in this direction. And I tried to mention that several times here, where a particular product or a particular individual or a particular trend got me exploring a bit, and so here we are.
Okay, well, I think we're about 2 hours in. I think
Really?
we're
Wow.
about done. Yeah.
All right.
Okay, thanks so much, Tony.
It was my pleasure. I enjoyed it.